Greetings to all the viewers. Now we are going to discuss about the compound called caffeine. Caffeine is also called as alkaloid. Caffeine is the part of alkaloid. The session is purely AI powered. Now we will discuss about the natural alkaloid called caffeine. The compounds whatever mentioned over all are accompanied by the alkaloid called caffeine. Let's go with that. Caffeine is a naturally occurring stimulant, most commonly found in coffee, tea, cocoa, and various other plants as well. It also forms stimulating effect, right? Coffee, tea, cocoa. Cocoa is the part of chocolate. Coffee, tea is most familiar to all the human civilization, right? And other plants also, from other plants also, we are able to extract that one, right? So especially caffeine used to stimulate is nothing but activate the systems, central nervous system, right? The nervous system is categorized into two: central nervous and peripheral nervous system will be there. Central nervous system included with the brain and spinal cord. Peripheral nervous system is nothing but which are extended from this system, right? So here central nervous system is stimulated by means of this caffeine, and making it one of the most widely consumed active substance worldwide. Most of the people are familiar for coffee, tea, everything, chocolates. So like this, and even soft drinks we are consuming. So that caffeine is the natural alkaloid whichever present. So it used to stimulate or activate our entire nervous system. That's the reason why it is most actively consumed throughout the world, right? Chemical formula C8H10N4 and O2, right? So this is about the empirical chemical formula for this caffeine, and the molecular weight of this caffeine is given as 194.19 gram per mole, right? So here C8H10N4O2 is given like this. So if you observe, you can find it is the fused system where you can notice the heterocyclic rings. Two heterocyclic rings are present. So this cyclic system is having nitrogens at 1,3 position, here also 1,3, and this is a kind of natural ingredient where you can find four nitrogen heteroatoms within the annular system, and two ketonic functional groups are located, and all the nitrogens are methylated except one. All three nitrogens are methylated. Another one is tertiary. So this is the way entire system structure of the caffeine is provided. So without mentioning methyl also, another representation is provided over. Here you can find methyl, here methyl, here methyl is there. So both are synonymous in nature, right? So this is the way chemical formula and the chemical structure is provided for this caffeine, and the molecular weight is given as 194.19 gram per mole. Chemical name of the compound, so chemical name of the compound is 1,3,7 trimethylxanthine. If these three methyl groups are not there, that is indicated as the xanthine core, and upon you can find three methyl, so that we can say trimethylxanthine. Trimethylxanthine is the name of the compound. Caffeine belongs to the xanthine alkaloid. So here alkaloids are the different classes. Quinoline alkaloids will be there, isoquinoline alkaloids will be there, piperidine alkaloids will be there, and this is the way xanthine. It is the caffeine is the part of what? Xanthine alkaloid. It is the class of xanthine alkaloid, which also included in theobromine and the theophylline. Theobromine and theophylline. These two alkaloids also composed by this xanthine. Okay, xanthine present in caffeine. At the same time, theobromine and theophylline also having a resemblance with this xanthine skeletal moiety. The structure consists of purine base. Here, this part, purines and pyrimidines are most important in what? Our DNA system. That is the genetic matter. Deoxyribonucleic acid will be there, no? So that purine base is present in this caffeine. That's the reason why it is working upon our nervous system, and it used to activate and stimulate our nervous system, right? The structure consists of purine base. So this is the part of this, the skeleton, whatever we are seeing, that is a purine base, and mostly it is resembling adenine and guanine, right? Adenine, guanine are the kind of purine bases, pyrimidine bases, both are used to connect in particular manner, and the entire twisting in order to manufacture that DNA. Our genetic matter will be there. Some extent that same kind of resemblance you can observe in this caffeine as well, right? And you can find three methyl groups attached. Trimethylxanthine derivative, it will be trimethylxanthine derivative. This is the way description regarding this caffeine is provided. Now let's go with the sources of caffeine, from where we can extract this caffeine, right? So everybody aware that coffee beans will be there. From these coffee beans we are able to extract this caffeine. Coffee beans are one of the richest source of caffeine, with the average cup of coffee containing 70 to 140 milligrams of caffeine. Caffeine maximum content is enriched in what? Coffee, right? So this is the source we can notice. Tea. Both the black and green tea contains the caffeine. Okay, black and green tea contains the caffeine, and smaller amounts in smaller so that tea also accompanied by that stimulating property. That's the reason why this caffeine is also this also present in this tea. Then cocoa seeds. We can collect cocoa seeds, and it is most important for the manufacturing of chocolates, and that also contains a caffeine. So coffee, tea, cocoa, from which we are able to extract the alkaloid called caffeine. Energy drinks. So energy drinks will be there. Instant energy giving drinks will be there. These often contain synthetic caffeine or extracted from the natural source, such as guarana. So here energy drinks, so especially athletes and other persons who requires the instant energy, at that conditions energy drinks will be consumed. In that also caffeine is present over. And soft drinks, whatever soft drinks we are consuming, those soft drinks, particularly Coca-Cola, we are aware about, and that contains caffeine, so which used to stimulate our brain and central nervous system, so that entire organisms are in particular alignment in order to work in effective manner. That's the reason why caffeine is the important alkaloid, so that most of the people can consume in the limited quantity every day. Mechanism of the action. Caffeine primarily works as a central nervous system stimulant by blocking the action of adenosine. Adenosine used to give the sedation. We are able to sleep. It used to suppress the activity of the brain, so that we will go for the sleeping tendency. Adenosine, that activity will be suppressed. So the central nervous system will be activated by means of this caffeine, so that we will get promoted from the sleep and relaxation process, and sedation tendency will be removed. Adenosine normally binds to the receptors in the brains to slow down the neural activity, but caffeine compete with the adenosine, so that receptors will be activated, so that that giddiness, sedation, sleeping tendency, whatever the kind we can say, everything will be mitigated. This is the way the working action of the caffeine will be there. Pharmacological effects of the caffeine. Caffeine is the main purpose of the caffeine will be stimulation. Stimulation means it activates our brain. Whenever our brain is active in a proper condition, then entire activities and the proper mechanism, whatever we are working in the particular manner, it increases the alertness, attention, reduces the perception of fatigue. We will never feel that we are bored, we are tired, we are not able to continue, and so that tendency will be reduced, so that alertness will be there. So that caffeine is regarded as stimulant. It improves the cognitive function and the concentration, especially sleep deprived individuals. Okay, so cognitive function, so whatever sharpness of the brain, so that thinking of brain will be enhanced because of the alkaloid called caffeine, and it improve the concentration. Focusedness will be improved by means of this caffeine. And physical performance. Caffeine can enhance the physical endurance and reduce the perceived effort during the physical activities by mobilizing fatty acid from fat tissues, improving muscular contraction efficiency, right? So physical performance indicates what whenever caffeine consumed by the person, which used to muscular mobility will be in a proper way. Whenever our muscles are moving according to our will, what happens, we will work in a spontaneous manner. That's the reason why muscular action is a spontaneous, because of this caffeine activity will improvise this kind of this kind of muscular functioning. This is called physical performance, so that the person will be active mentally and physically as well. Mood and mental health, so that whenever the people who are taking this coffee or else tea, what happens, they are in a kind of binded manner. They used to improve their positive thinking. So that's the reason why it used to induce it will impact our mood and mental health as well, so that we will move far away from the depression and that kind of negative impact on the health. Metabolism. Caffeine stimulates the body's metabolic rate, which is why commonly included in the weight loss products, right? So whenever we are consuming caffeine in the prescribed manner, so it used to enhance the metabolic rate. So metabolic rate is nothing but whatever biological activities carrying inside, that metabolic activities got enhanced. Whenever metabolic activities are in the optimal level, a requisite level, what happens, so the entire fat content will be burned, calories will be burned in a sufficient manner, so that the person or people are able to reduce their weight. So in that manner also it will work. Caffeine used to stimulate the metabolic rate, so that calorie burning process will be in a proper way, so that weight loss is the output of that kind of metabolic rate. So this is the way metabolism is also impacted positively by this caffeine. It promotes the release of adrenaline. Adrenaline is the hormone which released, so which whose activity will be enhanced by means of this caffeine. It increases the heart rate. Heart functioning is in a proper way, mobilizes the energy sources. Whatever the continuous heart contraction and elongation is very essential in order to pump the blood very sufficient in a convenient manner. That's the reason why adrenaline used to give the energy to make the heart rate in a proper way. That's the reason why this caffeine is also work upon this secretion of adrenaline in the sufficient quantity. And next is about diuretic effect. Diuretics are nothing but the kind of substance which works upon the proper functioning of the kidney is called a diuretic. Caffeine has a mild diuretic properties, meaning it can increase the urine output. Proper dialysis by the natural filtration device called the kidneys can be easily carried by the consumption of the caffeine. So it have a mild, that means a little effect over there, but it also having its own impact, its own effect on this diuretic property. A proper secretion of the urine, proper dialysis process got carried naturally by means of these kidneys and the entire, what we can say, nephron system, right? However, tolerance to this effect develops quickly in regular users, right? Medical and therapeutic applications, headache and migraine treatment. Headache and migraine treatment. The people who are suffering with the headache and migraine, at that condition, if you are consuming that chocolate or else coffee or else tea, that will give the positive effect and it will give the relaxation tendency, so that we are immediately move away from that kind of headache and migraines. So that caffeine is used in the treatment of headaches and the migraines. It often combined with the analgesics whenever we are binding. So during the pharmaceutical usage of analgesic, if we are blending this caffeine with this analgesic, what happens? It use the enhance that kind of what pain relieving tendency. It will add it will be added advantage to that pain relieving tendency to enhance their effects by narrowing the blood vessels and increasing the drug absorption. Effective absorption of the drug wherever it is required inside the human organs. So that is also improvised by means of that alkaloid called caffeine. Caffeine finds multiple multi-dimensional applications over here. And the next is about the premature infant apnea. Caffeine is used as a respiratory stimulant. That breathing system entirely works very smoothly. The people who are consuming this caffeine on daily basis, right? So the requisite amount of caffeine is mandatory to accommodate into the human organisms in order to work properly this respiratory system as well, so that the newborn the pain tendency that also get mitigated. And neuroprotective effects. Caffeine obviously used to protect the always we already aware about it is the stimulant, no, so that it directly works upon the nervous system, so that neuroprotective properties obvious for these kind of caffeine, so that our nervous system will be in a particular, that means it will be healthy, our nervous system will be healthy whenever caffeine consumed in a requisite quantity. Some research suggests that long-term moderate caffeine consumption may have neuroprotective effects and might reduce the risk of neurodegenerative diseases, right? So nervous system slowly degraded, its functioning will be slowly retarded. At that condition, neurodegeneration is possible. Nervous system is only the driving force for us. Whatever things we are feeling, so the heat, the taste, the smell, all these are regulated by this entire nervous system only. Whenever nervous system is working properly, then only we are able to communicate with our surroundings in a harmonical manner. So whenever that system is slowly degrading, what happens? The response, whatever coming from that person who are suffering, will become slow down. So that risk of neurodegeneration will be lowered by means of this caffeine consumption. So whenever neurodegeneration will be there, there are subsequent impact we can notice, that is Alzheimer's and Parkinson's. Alzheimer's is nothing but we are not able to remember the things in a proper way, and Parkinson's is the disease that is due to neurological disorder. The particular parts are not able to work in a proper way, so that is the Parkinson due to the insecretion of dopamine, right? So these will be mitigated, this will be retarded by means of the consumption of caffeine. Industrial usage, pharmaceutical industry. Caffeine is used in combination with the pain relievers like aspirin and acetaminophen to treat migraines and tension headaches, right? So if the person who are suffering very tiredness, anxiety will be there, total giddiness in the brain, or else tension headaches are present, at that condition, this caffeine is effective medication to cure the entire symptoms, whatever generated over. And the beverage industry. Apart from the natural occurrence, caffeine is added to energy drinks, colas, and other beverages to provide the stimulating effect. All these are regarded as soft drinks, right? So whenever you're using energy drinks in order to get the instant energy, and colas will be there, soft drinks. Coca-Cola is all added is used with added flavor of caffeine, and other beverages also accompanied by this kind of caffeine, so that whenever we are consuming them, we will feel the activation, that is because of the presence of this caffeine. Conclusion. Caffeine is a widely consumed stimulant with a range of applications enhancing alertness and physical performance. To its use in the medical treatment. While moderate consumption is generally safe and may even offer health benefits, excessive intake can lead to the adverse effects such as insomnia. We are not able to sleep. Insomnia denotes what? Sleeplessness, anxiety, dependence. So that means addiction property will be there. So anything in the optimal or requisite quantity is only the sufficient one. So whatever quantity we require, that extent we need to consume, so that health benefits are positive whenever we are consuming in a sufficient quantity. That's the reason why most of the caffeine alkaloids extracted from the plant materials and finds a larger extent of health benefit effects. Now we entered into another segment called the structural elucidation of caffeine. The structural elucidation of the caffeine is determining the exact arrangement of atoms within the molecule, including bond connections, stereochemistry, and functional groups. So, what is meant by structural elucidation? Exact. So, what arrangement is there within the molecule, and how the atoms are got connected, and what is the orientation of all the functional groups called stereochemistry, and what kind of functional groups are located over the entire things will be elucidated are determined by means of structural elucidation process. Tools and techniques used for the structural elucidation of caffeine. Initially, we will go for the elemental analysis. Elemental analysis denotes what individual elements of the formula will be depicted. So, how much percentage of carbon is there? What is the contribution of hydrogen and nitrogen? How many atoms are there? And how extent oxygen is present in this caffeine, so that we are able to identify the presence of individual atoms and their percentages as well. Based on that elemental analysis, we concluded its molecular formula will be C8H10N4O2. This will be the molecular formula of what? Caffeine. So this will be the kind of representation of its chemical composition, where we can find a purine core over there, adenine and guanine resemblance we can clearly notice, and three methyl groups are located on the nitrogens, and ketonic functional groups are also present. So this is about the representation, where you can notice the bonds. Simply bonds present on the nitrogen indicates what the presence of methyl group over there. So a alternative way. So these two alternative ways we can represent this caffeine. Mass spectroscopy. Mass spectroscopy helps to determine the molecular weight of the caffeine. So, according to this mass spectroscopy, its molecular weight is determined as 194.19 gram per mole. 194.19 gram per mole is the molecular weight for this kind of molecule. Fragmentation pattern. Being it is a kind of biannular system, bicyclic system, so that we have to fragment in order to get more convenient way for the determination. So that fragment analysis is also the part of this mass spectroscopy. Example, if you are getting peak for M by Z, mass by charge, 194 indicates the molecular ion of caffeine. So molecular ion denotes what? 194 is molecular weight of this one, no? M by Z value we got 194 as well. So that means the whatever entire molecule is there, that molecule entirely taken over. So this is the molecular ion peak. Entire composition will not be fragmented initially. That is the molecular ion peak given by this mass spectroscopy. Always the values are studied in M by Z values. Let's go with nuclear magnetic resonance spectroscopy. NMR spectroscopy is either proton NMR or C13 NMR. Proton NMR used to observe about the environment of the protons, and C13 NMR regarded for the nature of the carbon atoms. Proton NMR spectrum determines the number of hydrogen atoms and their environment. In caffeine, hydrogens are attached to three methyl groups. If we observe here methyl, here methyl is there, so that all three hydrogens are of different environments, so that we can mention them as A, B, and C. Though all are methyl only, but not having similar environment in their surrounding, so that we have to designate them in a different strategy. A is given for this methyl, B is given for this methyl, C is given for this methyl. This nature, this distinctness among these methyl groups can be depicted by this proton NMR spectrum. Apart from this, here also you can notice another peak for this fourth hydrogen, that is imidazole ring hydrogen, right? So that we can experience this sorry, A peak regarded for this methyl. A methyl protons will be there, and B methyl protons are given for this one, and C methyl protons are given for this one, and D methyl protons at the downfield shift. So values recorded as parts per million ppm, and TMS taken as a internal standard in the proton NMR. C13 NMR, which gives the nature of the carbon atoms, so that provides the information about the number and the environment of the carbons. Caffeine has a signals corresponds to carbon atoms. In its methyl groups, two ring systems are located, and we already aware this is called purine ring. Carbon atoms in the purine gives the characteristic chemical shift. So chemical shift values of individual carbons are distinctive, so that we can easily analyze what is the skeletal structure of this what caffeine. And next we move by using this proton NMR and C13. What we observed, what kind of methyl groups are present, and what kind of hydrogens are located over, and what is the nature of carbon. So this is about nuclear magnetic. Now we entered into infrared IR spectroscopy. IR spectroscopy is plotted in between wave number in centimeter inverse versus transmittance. This is the way the graph is plotted, and always it is characteristic. Sorry. Always it is characteristic for what? IR spectroscopy is characteristic for functional group identification. So based on this IR spectra of caffeine, we can observe that here we can see carbonyl group is there. That carbonyl group is a distinct peak at 1650 and 1700 centimeter inverse. Sorry. 1650, where you can see 1650 is there. In here the broad peak we can notice over 1650 peak is there. This peak corresponds to what? Carbonyl group, presence of carbonyl group. And another NH stretching will be there. This NH stretching is observed at 3100 to 3500. You can clearly observe another broad peak. You can notice this around 3500. That is for what? NH. So the purpose of IR spectroscopy is for functional group identification. We noticed there is the presence of carbonyl and NH. This is confirmed by IR spectroscopy. Let's move on to ultraviolet and visible spectroscopy, which is designated as UV visible. If you go with UV visible spectroscopy, caffeine absorbs UV light due to its conjugated system. So conjugation is present within the molecule. Here is the conjugation. So here exocyclic double bond and endocyclic double bond both are in conjugation. And here also, from this double bond to this double bond, you can notice extended conjugation. We can notice here to here, here to here. Extended conjugation is located within the molecule. That's the reason why caffeine is able to give the characteristic ultraviolet visible spectroscopy values, maxima values at 270 nanometers. Absorption spectrum provides the additional information about the conjugation in the electronic system, that is a purine structure. Here, the graph for UV visible spectroscopy of caffeine is plotted among wave number in the centimeter inverse against absorbance. These values are taken always. UV peaks are indicated as the broad peaks, and the distinctive information regarding the conjugation is observed over by means of ultraviolet spectroscopy. Let's move on to another segment of analytical identification technique called X-ray crystallography. The nature of crystal can be identified by means of this X-ray crystallography. X-ray diffraction is one of the most definite method determining three-dimensional structure. Right, X-ray crystallography, what is the purpose? Diffraction method, whenever we are passing X-rays through this molecule, that used to give the three-dimensional structure of the caffeine molecule will be determined. So caffeine X-ray diffraction studies are mentioned over. Caffeine crystal can be analyzed using X-ray crystallography to determine the exact bond lengths, bond angles, arrangement of the atoms in the molecules. According to the Bragg's equation, this extra X-ray crystallography technique will work and used to give exact what is the angle, what is the length, and arrangement, the proper orientation of the molecule entirely determined by means of X-ray crystallography. Let's move on. By this, we completed the process called what? Structural elucidation. So the step-by-step determination of analytical determination of structure of caffeine got completed. Now we entered into the segment called structure of the caffeine. And after this entire structural elucidation, it is confirmed that molecular formula of the caffeine is provided as C8H10N4O2. Right? This is the molecular formula for the compound. And according to IUPAC, IUPAC is the international standard in order to provide the name for all the organic compounds, International Union for Pure and Applied Chemistry. According to that, 1, 3, 7 trimethylxanthine. 1, 3, 7 trimethylxanthine is the IUPAC name for this caffeine. According to the structure of the caffeine, we can observe a few key features over there. Purine skeleton will be noticed. So whatever blue shade you can observe, that is denoted as a purine skeleton. One is a 6-membered ring and another is a 5-membered ring, where 4 nitrogens are allocated in the manner. And here here is the 6-membered, and this is the imidazole ring. We can notice this is the purine ring system, right? And fused 5-membered ring system. So this 6-membered ring denotes a purine system and 5-membered ring denotes what? Imidazole ring system will be there. So, and we can observe 3 methyl groups over that. Those 3 methyl groups are mentioned with these orange shade, and which are located on 3 nitrogen atoms at the position. We can designate this N1 and 3 and N7 positions. This is the way methyl groups are mentioned on this purine ring. 2 carbonyl groups. So if you observe this entire skeleton, there 2 carbonyl groups are located. These carbonyl groups are imparting amide structure for this molecule. Here is double bond O. Here another double bond O is located. The position of double bonds are C2 and C6. So this is about the key features regarding the caffeine molecule. So this is a confirmation we got by entire analytical structural elucidation process. Now we got the summary over there. Elucidation of caffeine structure involves identifying purine skeleton, presence of methyl groups and carbonyl functionalities. Modern analytical techniques we used we gone through NMR, nuclear magnetic resonance spectroscopy, IR, infrared spectroscopy, MS, mass spectroscopy, X-ray diffraction crystallography. Provide the detailed information about the molecular structure. Through these methods, caffeine complete molecular structure, including bond connectivity and the functional placement, has been well established. So by this, we can clearly observe the entire structural confirmation got carried by these advanced analytical tools, so that you can observe in methyl, double bond go, and conjugation over there, and fused ring system will be there, methyl will be there. So this entire structural confirmation got carried by means of what? This analytical observation. So we completed another segment called structural elucidation. Now we entered into another part of the system called synthesis. So that synthesis of caffeine is carried by two alternative methods. Natural extraction got carried by taking plant extract. Plant juices can be converted into a caffeine, or else alternatively within the laboratory also we can go for the synthesis of caffeine can be synthesized in the laboratory as well, right? This is the process used commercially to obtain natural extraction. We are discussing about natural extraction of the caffeine is the process. Commercially we can obtain the caffeine from the plant materials. Caffeine is found in coffee beans, tea leaves, cola nuts, cocoa beans, and yerba mate. So these are the sources from which we can extract the caffeine. Coffee beans will be there, everybody aware about that one, and tea leaves will be there. From that you can extract. Cola nuts will be there. Cola nuts, Coca-Cola is also having caffeine, right? In that cola nuts also we can find this caffeine. So cocoa beans, they are used in the manufacturing of chocolates, and yerba mate will be there. I'm not aware about this one. So these are the sources about the extraction of caffeine. And the next is about extraction process. Preparation. Step one, we have to go for its preparation. First of all, before extracting, we have to prepare that one. Plant material is dried and finely grounded. First of all, we have to dry the entire plant materials, whatever we are collecting, that should be properly dried. After drying that one, so the fine powder we have to prepare. Finely powdered one we have to make. Next is about solvent extraction. Solvent extraction means what? So whenever we are taking all the plant extracts, what happens? There are complicated molecules. That means so many materials are present within. Whatever caffeine we exactly require, that should be isolated. In order to get the isolation, solvent extraction is very important. The grounded material is treated with solvents like water or else supercritical carbon dioxide. The purpose of solvent is, if that caffeine is dissolved in this solvent, it will be separated. Whatever water insoluble substances are there, they get discarded. We can treat them as a side products or unrequired one. So that solvent extraction, we can dissolve the caffeine alkaloid inside the water, or else a critical carbon dioxide can be used over there, so that caffeine will be taken into that petri dish. The extraction efficiency depends upon the factors like temperature and pressure. By maintaining optimum temperature and pressure, we can go for the effective extraction of this caffeine by means of suitable solvent. Separation and purification. The exact extract is purified to isolate caffeine by filtration and evaporation. Whatever we taken into water or else critical carbon dioxide, we have to place in a proper way, so that we have to go for the filtration. Caffeine is being it is a solid, can be separated from that water, or else evaporation can be applied in case of carbon dioxide, right? So this is the way separation and purification got carried in order to get the crystals. You can notice the crystals of caffeine over there. Crystallization. After the extraction, now we gone through this extraction process. Extracted material got filtered or else evaporated in a proper way. Now it can be treated with the solvent. Suitable solvent we have to treat. Again, here solvent treatment is required. Whenever solvent treatment was done, again impurities got discarded and purely caffeine will be soluble. For example, we have two materials inside that petri dish. Two materials are there in the petri dish. Caffeine is soluble in water. The second compound is insoluble in water. If you are pouring water, what happens? Caffeine will dissolve and another material will be in a solid form only. Simply you can filter so that crystals of caffeine will be segregated in that manner. This is the way extraction or crystallization got carried. And it's very simple. We can observe within 4 steps, it is possible to extract from crude caffeine to the pure caffeine. This is the way we can go for natural extraction process. Let's go with the another alternative method called chemical synthesis. Within the lab also, it is possible to synthesize. Very simple step you can observe, theobromine method. Theobromine is nothing but it is the starting material we are taking. Most commonly studied route for the theobromine synthesis only, and naturally occurring xanthine alkaloid, which is found in cocoa. So theobromine structure is provided here. You can clearly observe. Only the difference is for this caffeine to theobromine is absence of one methyl. Simply, theobromine extracted from cocoa. This cocoa extract was taken and subjected to methylation at this position, so that within one step, it is possible to make theobromine into caffeine. This is the way methylation of theobromine is sufficient for the conversion of starting material into the product. Theobromine can be treated with any methylating agent. Convenient reagent will be methyl iodide under suitable basic conditions, alkaline conditions. We have to go for the synthesis of caffeine, and remaining all methyl are already there, so that only the requirement in one position got methylated. Sorry, in one position got methylated by means of this theobromine enalkylation process. This is the pathway number 1. Let's go with another method, which is called what? Trobe synthesis. Trobe synthesis started from the starting material, which is called cyanoacetamide. The cyanoacetamide will be taken and is treated with urea. Whenever cyanoacetamide treated with urea, the formation of uracil. Uracil is a what it is, DNA base, right? Uracil is the DNA RNA base. It will be 6-amino uracil will be synthesized. Cyanoacetamide treated with urea, 6-amino uracil will be manufactured. After getting 6-amino uracil, any methylating agent if you are treating with, so that simply we can convert this uracil into a caffeine. Just now we indicated that caffeine is resembling with either guanine or adenine. There is a slight change between the uracil and the guanine adenine, right? So that whatever uracil part we are having, by adding with methylating agent, simply we are able to convert into a caffeine. This is the one we can start with cyanoacetamide. Let's go with another methodology, methylation of xanthine. Already we are aware that xanthine core is located. Xanthine core it is the class of caffeine is the class of xanthine, right? So that xanthine will be taken. Sorry, not this one. This is also the kind of xanthine, but here whatever we have. Sorry, this moiety whatever present, this is the core which is called xanthine core, and that kind of xanthine was taken and treated with methylating agent, right? If these three methyl groups are not present, that core structure is regarded as a xanthine. Let me show the clear vision. Whatever blue shade you are observing here, the blue shade particularly denoted as a xanthine part in our caffeine. So that this xanthine starting material we have to take. Whenever this blue shaded part was taken and subjected to methylation, that methylation giving rise to how many we require? 3 methylation. 3 moles of methyl iodide is required, so that this blue shaded part will be alkylated at C1 position, and this is called N3 position, and this is called N7 position. So N1, N3 and N7 positions got alkylated upon xanthine. This is the one started with xanthine. So three alternative methods we gone through, but though we are having three different methods, all the methods are only one step process only, or else a two-step process. Sorry. In the thiobromine, what we are taking, thiobromine, only one step alkylation required to make the caffeine. In case of cyanoacetylide, cyanoacetylide should be added with the urea and subsequently further methylation is required. Only two steps are required for this Traube synthesis. Go with xanthine. Xanthine was taken and added with 3 moles of methyl iodide so that caffeine will be synthesized. Very simple to understand the process. Alternative methods are so many so that caffeine can be synthesized within the laboratory in these multiple ways. Now we will go with the applications of the synthetic caffeine, where we can apply. Why we are synthesizing in these many ways? Because we find applications over there. Let's see what are the applications for the caffeine. In the pharmaceuticals, caffeine is commonly used in medication to treat the headache and migraines. Already we are aware that daily consuming coffee or else tea, that will give the relaxedness. That is because it is having stimulation of the brain, stimulation of the central nervous system. So that whenever caffeine is added to the medicine, so that headaches and migraines will be mitigated, and fatigue conditions. Fatigue means what? Tiredness can be removed by the addition of this caffeine in food and beverages. Food and beverages, caffeine can be added to the soft drinks, energy drinks, and other food products as well, because it used to enhance the activity or effective working of our brain and central nervous system. Research. Caffeine is used in the scientific research, particularly for its role to understand neurotransmitter activity and energy metabolism. Effective effective usage of energy by the entire system. For example, we are consuming the food, but it is not completely metabolized. What happens? That will be stored in the form of fat, or else any other material will be deposited within the body. So that will give the another adverse effect. So that effective metabolism of energy is possible by means of this caffeine. In conclusion, caffeine can be obtained naturally through the extraction from the plants, or else we can synthesize within the laboratory as well. So many synthetic routes are available. Most common being is the methylation of theobromine. Though so many are present, theobromine thing is the common one. This is the way. We gone through the entire discussion regarding the caffeine. Caffeine is the alkaloid containing the purine ring, or else we can say xanthine ring, or else we can say that fused bicyclic ring it will be. And its initial introduction or requirements we gone through. Next, structural elucidation part we discussed about. Later on, we gone through the synthetic preparation of that caffeine, followed by effective applications in our daily life. All are mentioned in the systematic manner. Hopefully, the session is informative for your understanding. Thank you very much for your patient listening. This is Dr. Kavita Kottireddy Kota. Thank you. Thank you, one and all.